Hi everyone, welcome to our video on finding the limits that involve complex fractions, like these two here, where you have fractions in fractions, and then a piecewise function that we'll deal with, and then an absolute value function that we'll deal with at the end. Okay, so we left off, just as a quick reminder, if they're polynomials, or if it's a polynomial divided by a polynomial, we usually look to factor. Again, usually first always plug in and see what happens. If you get 0 in a denominator, then this is our strategy afterwards. So often we have polynomial over polynomial, so factor. When you have radicals, so the square root there, we usually multiply by the conjugate. And then now we've got our complex fraction strategy. Okay, so let me kind of just block this off. There we go, so it kind of snuck in there. Anyway, so just like all of them, still plug in the -5 into your letter, or whatever the number is, into the letter. So if we do that, we'd have 1 over -5 would become -1/5. And then -5 squared. Now, -5 squared is -5 times -5. That is positive 25. And so 1/5 minus 1/5 is 0. 25 minus 25 is 0. Okay, so we have the 0 in the denominator again. So that means we need to work on this in some other way. All right, well, the way that we're going to do this is I'm going to use my implied parentheses. So let's get that whole thing right there. And then all we have to do is look at the denominator of our small fraction. So that 5w. Actually, let me use a highlighter so we can see it better. So we have the 5 down below, and we have the w down below. So all we do is look at I call these small fractions in our big old fraction. So the big old fraction's the whole thing, and then you have these fractions inside the big fraction. Okay, anyway, so all we do is we see, 5 and w are the denominators. So that's what we're going to multiply both the top and bottom of our big fraction by. So that's all it's going to take. And up top, we would distribute. The bottom, we just leave alone. So distribute where you have fractions that because what we're going to do is get rid of these fractions. So we distribute where we see the fractions. Where there aren't any fraction portions, we just leave as is. Okay, so what this becomes is the limit as w goes to -5. Big fraction. Again, the denominator, let's just go ahead and take care of now. So since nothing's going to change, it looks like that. And then now, when we distribute this 5w through, well, 5w, and let's show it. Let's go ahead and show it this time, and the next one will kind of save a step. So 5w times 1 is 5w over 5, and then plus 1 over w times 5w. Well, again, 1 would times the 5w. So the 5w is just going in the numerator over w. Okay, and now what's going to happen is up top, so let's write our limit as it goes to -5. Let's go ahead and just get our denominator first, I guess. That doesn't take any work. Let's just rewrite it. Okay, and then what we have, so once that 5w multiplies those numerators, well, look at this. This 5 and that 5 would cancel. So I'm left with just w, and I guess it's really w over 1, but we don't need to write, when you have something divided by 1, we know it's just the same old w or same old thing. Anything divided by 1 is the same old anything. So that w over 1, we're just going to write as w. And then this w over w cancels, so I'd have 5 over 1, but again, I don't need to write the division by 1, so it looks like this. Okay, and so what we just did is now we don't have fractions anymore, but nothing cancels yet. So we usually want something to cancel. Well, look at this denominator. Here we've got w squared minus 25. So usually if there's a quadratic, so if it's a higher power than 1, we look to factor. So in this red, I'll keep it in red, we're going to factor that. So this becomes the limit as w goes to -5. So the top we'll just leave as is now, just w plus 5. And then in the denominator, well, this is the difference of squares. So this is w minus 5 times w plus 5. And then still that 5w is still just hanging out. So we don't want to forget it. There it is. Okay, so all of that works. So this one involved a couple of strategies. we eliminated the fractions, and then we also had to factor a little bit. But now we've got it. So now we see there's something that will cancel. And so let's rewrite it as the limit as w goes to -5 of, now up top, the w plus 5 canceled, which means we need a 1 placeholder. Down below, I still have w minus 5, and then the 5w. Okay, so the highlighted portions are gone. And then now I can plug in the -5. So -5 is going into our variable, into the w. And so what we have, again, notice I'm writing limit each time. Now, though, that I'm plugging in the -5, I would no longer write it. So -5 minus 5, and then 5 times -5. So there's all that, and then I'm still left with 1 up top. -5 minus 5 is -10. 5 times -5 is -25. And then now we can multiply. I have 1 over, this is positive 250. And that's it. Okay, so there it is. So we finally got it. We simplified it all the way, and that's it. Okay, and as a reminder, just to check, let's do this one with a calculator. Okay, so that's from a previous problem. I'm just going to go ahead and delete all. Okay, so I use Desmos, and so what I need to do, remember, it would prefer X over another letter. So if you do plug this in, well, you can see what happens. Let's see what happens if we plug in W instead. So 1 divided by W. It might understand, but I don't think so. So I'm using those implied parentheses, and then W squared minus 25. And so we can kind of see, hey, nothing's popping up. So that's why I just change it to X then. So instead of these W's, let's go ahead and change those to X. And then now we can see the graph. Okay, and then we want to look at -5. So here's -5. Well, we can see the decimal that it's near is 0.004. Okay, so 0.004 is a decimal. You could also use the table, and we want around -5. So -5 gives us undefined, but remember, we just want something near it. So -5.0001, and we get that. And so it looks like it's rounding to 0.004. Okay, and then 0.004 is going to be that 1 over 250. So 0.004, let's write that in. Okay, so this is 0.004 like that. That is the same thing. So you could use a decimal. Remember, I'm not writing out 0.0039999. No, I don't want to do that. Let's also check just the 4.99999, something like that. So we can see it's also getting very close to 0.004. Okay, so it looks like that. All right, and I'm going to let's go back to Desmos. So sometimes, okay, so I'm just going to go to Desmos in this. Let's leave. And you could use the scientific calculator to really make sure that it's the same thing. Okay, so the 1 divided by 250, and we see, 0.004, just like that. Okay, and you can convert it to a fraction. Okay, so that could be helpful on other problems. Okay, so sometimes decimals aren't wanted, so you could just click the thing and get a fraction. Okay, anyway, so that's that. So again, you could always check these on the calculator. I mean, you could do the calculator first and see it, but it might be worthwhile to know both ways in case something gets typed in wrong in the calculator. Okay, so I would say it's always good to have a backup. All right, so looking at another fraction one, well, same strategy. So if you want to try this on your own, go for it. You could again, you could change these to X's and plug it into the calculator first if you prefer. Okay, so what we have, though, I'm going to do it only by hand. So I have my implied parentheses. And just like the last one, I just say, oh, these are my small denominators. That's what I need to multiply both the top and bottom by. So let me just extend this out. Well, first I should plug 0 in to verify that I'm going to get 0 over 0. And then I'd have 1/7 minus 1/7. Yeah. Okay, so that is 0 over 0. So our scratch work. Okay, so I want to make sure I do that first before anything. So that way, again, if this is some number, then we would stop and be done with it. Okay, anyway, so let's continue with this. So I would plug or I would multiply. So what I highlighted there is what I want to multiply. So all I do is 7 times 7 plus h on both the top and bottom. Okay, and the top doesn't have any fractions in it, so that means I'm just going to write that as is for our next step. So we have the limit as h goes to 0 of just h times 7 plus h. And then in our denominator, this multiplies each of these fractions right there and right there. And it's really only multiplying the numerator. Well, here's what's going to happen with this. Notice when this red, in the red, multiplies this fraction, this 7 plus h would cancel with this 7 plus h. So I'd be left with 1 times the 7. So I can really just write 7. And then when this in the red multiplies the second fraction, well, I do have a minus sign, so minus. This 7 and that 7 cancel, but I would still have 1 times 7 plus h. And then 1 times 7 plus h is 7 plus h. And then keep the parentheses in it for now because it's in parentheses here because this negative will distribute. Okay, and then when it does distribute, so I'm going to show with the arrows, but let's do 2 steps in one here. So I'm going to write my limit as h goes to 0 of just the top, just h times 7 plus h, over, well, 7 minus 7 would 0 out. Negative h would still be around. Okay, so the negative distributes, but I'm just going to go ahead and do 7 minus 7 to get 0. Negative h is still there. Okay, and then that way I can now see, oh, I have an h and an h that would cancel. So remember, it cancels this h. It doesn't cancel that one because it's 7 plus h is the whole expression. Remember, you can only cancel out expressions that have the same number of terms. So h and h is one term, 7 plus h is 2 terms, so they don't mix well. Okay, anyway, so the h's cancel, and we really have, we'd be left with a negative 1 down below. So we have the limit as h goes to 0 of 7 times 7 plus h over negative 1. Okay, because again, we need a placeholder. And then now I can plug the 0 in. And so it looks like I'm going to have up top just the 7. 7 plus 0, just to show it, I'll write it like that, over negative 1. Well, 7 plus 0 is 7. 7 times 7 is 49. Divided by negative 1 would be negative 49. All right, there it is. Okay, so that's how we could break that problem down. Okay, so that's our strategy with fractions. Now, let's take a look at these two kind of strange scenarios. So when you have a piecewise function, when it wants you to find the limit of a piecewise function, okay, so because you have two pieces, so this is a piecewise function, what we really need to do is 2 problems. We need to do 1. Let's find the limit as it goes from the left. And then our second one, let's also find the limit as it goes from the right. Okay, so we don't have to worry about left and right with these other expressions, these just algebraic expressions that are single functions. Because, well, when we graph them, for one thing, we can see it, that they do match from the left and from the right. However, with piecewise functions, we do have to check left and right because because they are 2 separate functions, and they're meeting at this 10. Okay, so for instance, what we can do on this, the one for the left, well, this function, let me go ahead and let's do it in blue. This function, this portion really, let me kind of bold that out. This is saying when x is less than 10. This is also saying when x is slightly less than 10. So it's from the left of 10. So it's saying use your 10 into this x into this problem. Okay, and if we do try to plug that in, we would have 100 minus, and I am now just going to plug 10 in exactly, so 10 squared is 100 over 10 minus 10, and then we get, it's 0 over 0. Okay, so that means I need to work on this in a different way. So let me go ahead and erase this. So sorry if you did ink, sorry about that. But what we're going to do is, let me go ahead and now just rewrite it. It really is just like plugging regular 10 in to this function. And when we did that, we did see 0 over 0, but we could say, hey, this does factor. That's a quadratic up top. So let's factor it as 10 minus x and 10 plus x over x minus 10. And well, we can use our strategy again where we see there's a minus, but the terms aren't matching. So what we'll do is factor the negative out. Let's factor the negative out of that one. And so we'll say that this is equal to the limit as x goes to 10 of negative, and then we're just going to switch the terms around, x minus 10 like that. And then I still have 10 plus x over x minus 10. And then that way the x minus 10s now cancel. And let's go ahead and do 2 steps in one since I'm running low on paper here. I can now plug this 10 into that x. I still have that negative, so I don't want to forget about it. But this does become, so I'm now doing the limit. I have negative 10 plus 10, which would be 20, and then the negative still out front. So I have negative 20, so I'm just going to cloud that for now. Okay, and then if I'm doing it with our right side, so we're going to save that answer for later. The right side of 10 is using this function. So this is saying x is greater than or equal to 10. Remember, this is saying just slightly right of 10. Well, if I plug that in, it looks like it is just a constant, and there's nowhere to plug x, so we just write that constant. It is just 20. Just like that. Okay, and then now all I have to do is compare the answers. We note that these two limits are not the same. One's negative 20, one's positive 20. Okay, so we've got the limit as x goes to 10 from the left does not equal the limit as x goes to 10 from the right. So that means that the limit from both sides does not exist. Remember that they have to equal the same number. If they are the same, if these were both positive 20, then our answer would be 20. If they're both negative 20, then our answer would be negative 20. Okay, and you could also graph these as well. Okay, so from Desmos, even you can click on, so from the scientific one, you can go to the graphing calculator. And these are a little tougher to graph, but just to do it real quick, I'm going to enter that first one. So parentheses 100 minus x squared divided by x minus 10, like that. And they say if x is less than 10. So notice it didn't work here the way they wrote it. So instead, what they use is a brace like that. And so they put it in braces. So that way we can get our piecewise function. And you can't really see all of it, but notice it stopped at 10. Okay, so that's how they deal with piecewise functions. And then we have another one. Just type it in the second line, 20, and then brace x greater than or equal to, so I just press the greater than symbol and then the equal on the keyboard, and then 10, like that. Okay, and we can see now we can treat it like one of our graph problems from before, where we can see, oh, from the left it's going to negative 20, from the right it's going to positive 20. Since they're not going to the same thing, that means our limit does not exist. Okay, so anyway, so again, the graphing calculator is very powerful as long as we understand it. So this is how we deal with piecewise functions. We just do them in separate lines with braces for their x interval. Okay, and then while we're here, so this absolute value function, when you have an absolute value function, it is best to just graph it. Okay, so absolute value. Let's just go ahead and graph it. Okay, so, because this one we can't really do in an algebraic way that's nice. We kind of have to manipulate things that are a little strange. So let's go ahead. I'm just going to delete all and start all over. Okay, so we've got parentheses x minus 1, parentheses divided by The absolute value is on here. You could do shift, or you could do this. Let me do this. Click on the keyboard, and you can see it right here. So I'll push it, and then x minus 1 like that. And there we go. Okay, and so we can see they wanted to see when x goes to 1. Well, look at this. From the left, we can see it's going to, looks like -1. From the right, it's going to what looks like +1. So because the left side limit and the right side limit are not equal, we know that this limit does not exist. Okay, so that one's nice to just plug in. And again, all of these you can plug into a calculator. Sometimes you have to change the letter. We went through some of them and did them. I skipped others. But on this side, just absolute value, just go ahead and graph it. And then from there, use your picture. Okay, so it looks something like this. Okay, so it looks something like that. And so since from the left didn't equal from the right, that's why it was a does not exist. Okay, anyway, so if you have questions on this, so this was all doing it by hand, so, well, except number 8, I guess. So sometimes they take a while. Be patient with it. Remember, you could check with a calculator, so, and I recommend Desmos. If you have a handheld one, that's fine too, but it's, I think, very easy to just, if you're on a computer, it's just right there anyway. Okay, anyway, so that's it. Thank you for watching. If you have questions, please let me know, and I'll see you next time.